Let's look at the first question in the network section of the 2021 paper. It talks about Maggie, who has 5 rooms which have 8 doors. All these represent the doors. And in other words, this means there's an axis, an edge connecting E and D. Okay. The floor plan has been given to you and the outside area F is shown. On this graph, there's a graph that represents this floor plan. And on this graph, the vertices represent the rooms and the edges represent the direct axis. Now this means direct axis. So there would have been an edge connecting E to D. One edge is missing. So I start from A, which is the topmost room, and I see that it has one edge through one door leading to F, and there are 2 ways to get to F. So if I had A and F, I would have had 2 ways to get from A to F. And then I saw there was another road that led to, door that led to B, and that would be B over here. There shouldn't be arrows. And I saw on the diagram there was no edge from A to B, and so I added that edge. What is the degree of vertex E? Now here we can see the edges leading out from E are 2. That's your answer. Maggie hires a cleaner to clean the house. It is possible for the cleaner to enter the house from the outside F and walk through each room only once, cleaning each room as he goes and finishes in the outside area. So the main idea behind this question is he starts at F. Sorry, it's Maggie. Maggie starts at F and she finishes at F and visits every room once. So when you visit every location, for example, if we say you visit every house once and you come back to the house where you started, okay, so house stands for H in the house stands for the Hamiltonian, and because you're visiting once and you're coming back to the same place F, it's a Hamiltonian cycle. So now they're asking you, complete the following to show one possible route that the cleaner could take. So going back to this diagram, you're starting at F and you want to finish at F, visiting each once. So if you were to follow this path, then you come to B, now you come to C, you come to D, and then you go to E. It's not possible to get back to F, so that won't work. So the one that we look at is another route which starts at F, of course, and you go to A, you go to B. Now if you had gone to E, then you could have come back to D, C, and then F. So F, A, B, E, D, C, back to F. The F's are given to you. If they're not, you have to add them in. Now the other way is going backwards, that is F, C, D, E, B, A, and F again. So that's going backwards. Okay, so F, C, D, E, B, A, F. That is why when you talk about Hamiltonian cycles, for every route forward, there's also the other route backward. And so that makes 2 here, okay? So any one of these can be given as an answer. So then they ask you what the mathematical term for this journey is, and as we discussed, it's the Hamiltonian cycle. Please write both the words. You can't just write one of these two words and get the mark. So question 2 says George lives in town G and Maggie lives in town M. The diagram below shows the network of main roads between town G and M. Then the vertices represent the towns. The edges represent the roads. The number on the edges represent the distances in kilometers between adjacent towns. So the very first, what is the shortest distance? Now, usually students find this question very time consuming. The shortest distance, so you need to get from G to M. So if I was to look at all the distances, one thing you have to remember in the question involving shortest distances, you don't have to touch every vertex, okay? So to take off from G, there are three options. Now if I go along H, to get to M, I would need to cover a large set of values, and that would be 46 plus 35, which would be 81. And instead, if I went along to J, so that would be just 30, but along that route, if I go and even if I go here, I have to cover another large set of distances, or I have to cover 50, which is an extremely large value I don't want to touch. And so let's look at along O. Now, if I look at the distance along O, I seem to actually have a small value here that I can touch. Now, in order to get to 16, which is the shorter of the two distances connected to M, I would have had to either come this way, which is a large value, or I would have had to come this way, which involves 50, which is a large value. And therefore, I found that the addition of 28 and 42, okay, added to 16 should actually give me the shortest distance, and that gave me 28 plus 42 plus 16. There are many ways of thinking about this, but it's a bit of a gamble, and you have to actually try to look for combinations of distances, and which could give you the least value. George plans to leave Maggie's house. He will pass through all the towns above. Okay. George plans to take the shortest route possible. Which town will he pass through twice? Now, what I have found from experience is it's always best to check out which towns you can't access through any other town. So that tells me these towns are in a sequence, and that town can't be accessed from any other town but K. Okay, so I have to do that. Now, if I have to cover 26, 20, 35, and if I have to cover J from there, I have to come down J, and then I don't have to go back to G because that's a starting point. So leaves me with, now because they're asking you the shortest distance, I really either could go 50 or I could, but if I go this way, I will not touch O. So I decide to go down, and then from O, the only option to get to N is that one, and from N to get to M. But then if I went to M, I would not be touching L. So I go back up here and then touch upon L to get to M. So clearly you can see that this particular vertex you touched upon twice. And that should be your answer. This question usually requires time. Anything to do with the Hamiltonian cycle or Hamiltonian path, usually you should leave it for the end. And then they're not going to be allowing UDFs from 2027. So it's important for you to learn the content. Bye. Happy learning.